Hi everyone, today we're doing some notes on negative exponents, so let's jump right in. Negative exponents for any integer n and any non-zero number a to the power of negative n is the reciprocal of a to the power of n. Okay, so let's look at an example of this with some numbers. We have 4 to the power of negative 2. Now, we just read that for any integer n, that's our exponent, and any non-zero number a, that's our base, a to the negative n power is the reciprocal of a to the n power. So a to the n power would be 4 to the power of 2. The reciprocal of that, well, we don't usually write it, but this is actually over 1. So the reciprocal of that would just be this flipped, right? We know the word reciprocal from keep, change, flip when we divide fractions, right? So the reciprocal of 4 to the power of negative 2 would be 1 over 4 squared. Let's go through a couple other examples together. 3 to the power of negative 4. Now, this one is very similar to the one that we just did. So we can make this positive and put it over 1. And then we know the answer is the reciprocal. So we're going to flip it. Okay, so we have 1 over 3 to the 4th power. You don't really need this step here in the middle. This is just to show that it's the reciprocal, and all we're really doing here is flipping it. Okay, but to go from step 1 to step 3, you're just making that exponent positive and flipping it. All right, let's take a look at the next one. So for the next example, we're going to need to use our quotient of powers property. We know when we are dividing two powers that have the same base, we subtract their exponents. Okay, so this becomes 2 to the power of 6 minus 8. When we do 6 minus 8, we get a negative number, right? We get negative 2. We want to write this with a positive exponent, okay? You never want to write your answer with a negative exponent. So to make this exponent of negative 2 positive, we're going to do 2 squared, and then we need to flip it, right? It's the reciprocal. So 1 over 2 squared. And now for each of these, we see that it says evaluating. If we are evaluating, I actually don't want to leave that exponent there at all. Let's continue evaluating each of these. I know that 3 to the 4th power, I can do that, right? You can type that into your calculator, or you could do the math in your head, right? 3 times 3 is 9. 9 times 3 is 27. And then we have 27 times 3. If you're not sure on 27 times 3, go ahead and check that on your calculator, or go ahead and use Desmos and just do 3 to the 4th power on your calculator yourself. But when we do 3 to the 4th power, we should get 81. So we have 1 over 81 as our final answer. Now this is fully evaluated, right? We're getting one final value as our answer. And this one's a little simpler. We're just doing 2 squared. 2 times 2 we know is 4. So 1/4 would be our final answer here. I'm going to have you guys stop and try a few problems on your own. And then we'll move right into example 2. Okay, so for example 2, we are simplifying expressions. Okay, so in this one, we're actually simplifying this expression. Now, again, I can see that we can use our our quotient of powers property here, right? We're dividing two powers that have the same base. They both have base y. Okay, so if it helps you, you can take this 9 out and rewrite it as 9 times y to the power of negative 3 over y to the power of 5. Okay, if that makes more sense to you, go ahead and pull that 9 out. And now we can really see that, hey, these two powers have the same base. All I need to do is subtract their exponents. So let's do that. Now we have 9 times -3 minus 5. Remember, when we have when we're using the quotient of powers property, we subtract the exponent. So -3 minus 5 gives us -8. Okay, and now this rule tells us to make that positive, we need to write it as the reciprocal. We need to flip it. So we keep this 9 on top, and we bring y to the 8th power into the denominator, okay? So we have essentially flipped y to the 8th power. It was over 1, now it's in the denominator, okay? And we're still multiplying across by that 9. So that is the simplified expression. Again, you're going to try a few problems on your own. And now we're going to jump right into our real life application problem. So the problem says a drop of water leaks from a faucet every second. How many liters of water leak from the faucet in 1 hour? Okay, and it says drop of water is 50 to the power of -2 liters. So convert 1 hour to seconds. That is step 1. We want to convert 1 hour to seconds. Now, the reason we're doing this is because it tells us a drop of water leaks from the faucet every second. Okay, so we need to convert this 1 hour into seconds before we can answer this. So we're going to go ahead and set up a conversion here. 1 hour is 60 minutes, right? We want to be able to cancel out these units. Now we want to cancel out minutes so that we get to seconds. So to cancel out minutes, I need them here in the bottom. 1 minute is 60 seconds. Now I can cancel out my minutes. Whoops. And this should be a multiplication sign, not an equal sign. There we go. Okay, and now we're just going to multiply across. So we have on the top 1 times 60 times 60, and on the bottom just 1 times 1. My units will be seconds. All of my other units have canceled out. So you guys can go ahead and do 60 times 60. 6 times 6, add 2 zeros. We get 3,600 seconds. So now we have completed our conversion. So let's take a look at the next part of the problem. It says water leaks from the faucet at a rate of 50 to the power of -2 liters per second. Multiply the time by the rate. Okay, so the time we have is 3,600 seconds. We're multiplying that by the rate, 50 to the power of -2 liters per second. Okay, now the reason we're multiplying these two things is because, look, just like when we did the conversion in the previous problem, seconds are going to cancel out. We're going to end up with liters. That will be the answer to our problem. The question had asked how many liters of water drips in that amount of time. So this will give us that answer. Now, in order to do this, I want to rewrite this 50 to the power of -2 with a positive exponent. Okay, so to do that, I need to make the exponent positive and flip it. It becomes 1 over 50 squared. All that's left to do here is evaluate this power. So 50 squared, I'm actually going to do 50 squared. Can do 5 times 5, 25, and then add 2 zeros. And then multiply across. I get 3,600 over 2,500 And I'm going to divide to get my answer. And we get 1.44 liters. So now we know the amount of liters that drips from that faucet after 1 hour.